In this video, we are going to discuss about counter type analog to digital converter. So this can be constructed using one comparator with a variable voltage VR. This variable reference voltage is obtained from DAC, that is digital to analog converter, and a sequence counter, that is here I have used a binary up counter. Okay, so consider if I want to convert 0.5 my analog input into digital output. Okay, so the output is taken from these 4 points. Since it is a 4-bit counter, I have used okay, see here it is n, this n value is equal to 4-bit. Okay, so this is my MSB and this is my LSB. Okay, so these are my digital output. Okay. So there is one formula. So the analog is equal to digital value into resolution into gain. Okay, so here if I take my gain and resolution is equal to 1, so therefore you can write okay, here I am going to take the gain value is equal to 1. Okay, gain is equal to 1, so I can write my analog by digital is equal to resolution. Okay, so what is my analog is nothing but input, right? So input by digital value is my output. Okay, so the resolution is equal to input by output. Okay, so consider I'm going to convert my input signal VA into a digital value. So the VA value is equal to 0.5. So initially here you have a reset pin. Okay, reset pin is nothing but active low pin. So if it is 0 means my output goes to 0. Okay, so if the reset value is equal to 1, this binary counter up counter will not work. Okay, so you can consider initially the reset pin is 0, so my the 4 pins are in 0 state. Okay, so what is VR? VR is equal to my digital value. Okay, so the digital value is nothing but 0 into the resolution. Okay, resolution. So here the resolution is I have taken R is equal to 1. So if that is the case, VR value is equal to 0. So since it is a comparator, so it if the plus value is greater than the minus value, my output goes to 1. If plus value is less than minus value, output goes to 0. So here you can see 0.5 is greater than 0. So my output goes to 1. Okay, so I have applied the clock. So it will start to count. So if it started to count, so it becomes this becomes 1. Okay, so okay, so I have applied one clock, right? So I have applied one clock pulse. So doing the one clock pulse, the binary output goes to 0001. So next, this now my VR goes to 1 into resolution, right? 1 into resolution. So since the resolution value is 1, so the VR value is 1. So now my V plus, so now this is 1 and this is 0.5. So the minus is greater than plus. So my output goes to 0. Okay, so if 0 into anything is 0, so it will not going to count further. Okay, so my output is nothing but 0 0 0 1. So this is my answer. Okay, so you can see if I want to convert uh, so the VA value is 0.5, my output is nothing but 0 0 0 1. Okay, so it will take only one clock pulse to convert my 0.5 value to a digital output. Okay, so now let me take this as sir. Let me consider another example. So for that is 2.1. So if it is 2.1, you can consider initially that is 0. Okay, so if it is 0, um, so the VR value is 0. I'm going to give one clock pulse, right? So first clock pulse. So my output is now it is 1. Okay, so it will started to count. Now it is 1, right? So 1 into 1 is 1. So this becomes a 1. Okay, so again my clock this is compared output goes to 1. I'm going to apply another clock. So now it is 1 0. It becomes 1 0, right? So this is the first clock and this is the second clock, right? And during the it is 2. So the VR value is nothing but 2 now. Okay, initially it is 0, next it is 1, now it is 2, right? So if it is 2, I'm going to apply another clock, right? Since the plus is greater than minus, so it will goes to 0 1 1, right? So 0 1 1. Now if you see during the fourth VR is nothing but 3. So the AND gate goes to 0. Okay, so the AND gate goes to 0. So there is no use in applying the clock pulse, right? So it will take so in order to convert my VR that is 2.1 volt, right? 2.1 volt. The digital output is 0 0 1 1, right? And 0 0 1 1, and it will take it takes 3 clock pulse for conversion. Okay, so you can see if my VR increases, okay, the conversion time is also increases, right? So suppose if so what is the limitation? The limitation is it can able to convert only a number from for VA is equal to 14.999, right? Because if the VA is greater than this value, it can't able to convert this analog input into a digital output. Okay, so the limitation is since because this maximum value of this one is nothing but 4 ones, right? The 4 ones represent 15 volt. Okay, so it will not convert a number which is more than this 14.999. Okay, this is one limitation. So I can write the minimum conversion time. So the minimum conversion time is 1 clock pulse, right? 1 clock pulse, unless if you give 0. Okay, so if the what is the maximum, and the maximum conversion time? Maximum conversion time is 15 clock pulse, right? So that is nothing but 2 power n minus 1. So here the n value is 4, right? So since the n value is equal to 4, um, it is nothing but 16 minus 1 is 15. Okay, so 16 minus 1 clock pulse. Okay, so I can write average conversion time. So the average conversion time is the maximum conversion time plus a minimum conversion, right, divided by 2. Okay, so that is nothing but 2 power n divided by 2 clock pulse, that is equal to 2 power n minus 1. So here you can see I can change the resolution, right? You can ask why the resolution time is resolution is 1. So if I make this resolution to r is equal to 0.5, okay, so the maximum it can go up to 15, right? So 15 divided by um, 2 is 15 divided by 2, because the VR is nothing but um, this digital output into 0.5, right? So it will go to the maximum values 7.5. Okay, so you can able to convert only the value up to VA is equal to 7.5, that is 7.499. Okay, so if though I reduces the resolution to 0.5, my conversion time is same. Okay, so it will not change, the conversion time will not be changed. Okay, so what is the advantage of this counter type ADC is it is very simple, right? It is very simple, and it requires less hardware, right? So it requires less hardware compared to the flash type ADC, and this is suitable for digitizing applications, right, with high resolution. So what are the disadvantages? I have already told you that if the input is higher, that is if the input is 14.99 volt, it will take more time to convert, right? More time to convert. If the amplitude of the analog input voltage is long, is high, okay, if VA is high, okay, because it start to count from 0 to the full scale voltage, right? So the conversion time is very low, so there is a disadvantage.